All right. Hello and welcome once again to a Mr. Slaney video on pre-calculus. Um, Today we're going to talk about end behavior of rational functions. Whoa, will this pen work? Yes, it will. Rational functions, otherwise known as horizontal and slant asymptotes. But I do want you to think of them as end behavior. This is not inherently different from our end behavior in the first half of the unit, where we saw like, hey, the limit as x approaches infinity of f of x equals, I don't know, negative infinity, and the limit as x approaches negative infinity of f of x is also negative infinity. This indicated that we were talking about a function in the first half of the unit that was down on both sides. So without knowing anything else, we knew that this function was down. When we got into our second half of the unit, we started saying like, hey, what if instead of down or up or that, we just leveled out? So what would a function look like if the limit as x approached positive infinity of f of x equals 4, and same thing with the limit as x approaches negative infinity of f of x, right? This says, hey, and I'm just also going to be a crazy person. This is my right behavior. This is my left. Can I spell left? Right, left, right? All this tells us about the graph, and this bad boy is also equal to 4. All this tells us about the graph is, hey, I'm level with that. And notice I'm not drawing anything in between at this point. I don't know, like, do I go up like this and down and then come back, like a little heartbeat? Do I have one of those, vertical asymptotes in between? This is just end behavior, all right? Now, this is a holistic video, so let's just take a quick look at another graph. Whoa! I like these doubles, right? We're going to go through 2. I'm going to make a little dotted line there so it looks like I'm leveling out at 2. If this were a graph of h of x, and I were asked for limit statements, right? Write the limit statements as x goes to infinity and negative infinity, right? I would just say, hey, I see this bad boy's leveling out at 2. So my limit as x goes towards negative infinity and my limit as x goes towards positive infinity, and this is what's my function? H of x. These are both equal to 2. These are both equal to 2. If I were then asked to identify from the graph the horizontal asymptote, I would say, ooh, that's a little low. Move that up a little. If I were to then ask, what is the horizontal asymptote? That would be y equals 2. These are all equal to 2. These are 2 different types of questions that I could ask about this graph where the answer is still 2 in some sense. Limit as x approaches negative infinity of h of x is 2. Limit as x approaches infinity of h of x is 2. These 2 just say on the left my function is 2, on the right my function is 2. Notice nothing in here talks about this, because this is, I didn't even mark. Let's put that bad boy at negative 5. This like craziness happens at x equals negative 5, not on the left or the right. This doesn't matter. Those ups don't matter, right? Limit same as x goes to positive or negative infinity. That's the horizontal asymptote. But what does this mean about equations? Onwards and upwards. This is where our cases come in. So now let's move on. Identifying slant horizontal asymptotes, horizontal based on equations. Case 1 is the even case. I'm going to put that in quotation marks because that's not really an official name. Case 1 is the most exciting because that's the ratio of leading terms. If I'm in standard form, right, y equals 3x squared plus 7x minus 8 over 2x squared plus 12, right? Standard form, no parentheses, nothing's happening too much. And the task here, the task is to identify the horizontal or slant asymptotes. Much easier in standard form. I see that this is case 1 because I've got two exponents of 2, right? Standard form, we just check exponents. Y equals 3 over 2. This 2, this 3. Boom. If I'm in factored form, y equals 5x minus 7, 3x plus 8 over 4x plus 1. Well, squared. How do I know that I'm in standard? How do I know that this is case 1? Well, I'm in factored form. I'm going to count my x's. 1, 2 on top. Mr. Slaney, I only see 1 on bottom. However, there's really 2 there because of that 2. So this is case 1 still. But now, watch this. My ratio of my leading terms is going to be 5 times 3 over 4 squared, which is 15 over 16. Right? Not only do I need to multiply the 3 and the 5, I need to square the 4. There's technically another 4 there. Whew, these are even. Good chance for a screenshot. Case 2. This is bottom heavy. Y equals, and I'll stay in standard form, x plus 3 over x squared. Just make it that, right? Boom. My horizontal asymptote be y equals 0. Always. Wicked easy. I'm bottom heavy. I'm cooking with gas. This is my standard form. This could also be as simple as like 5 over x plus 7. This is also bottom heavy. Also has a horizontal asymptote of 0. My, let me think. Factored form. And keep in mind, I'm looking at the whole polynomial, so I'm not looking at individual factors like I am when it comes to vertical asymptotes or wholes. Factored form. Y equals x plus 3 to the third, x plus 8 over 5x squared plus 1. Well, let's cube that bad boy. How many x's do I have on top? Same thing that I did before. I have 1, 2, 3 x's on top plus 4. I'm going to put a little 4. And I have 2 there cubed. I have 6 on bottom. Bam! Y equals 0 again is my horizontal asymptote. All right. We don't need to fool around with different numbers. Bottom heavy, wicked easy. If I wanted limit statements, the limit is let's go back here. Limit as x approaches infinity, and limit as x approaches negative infinity. Let's make this these are both 15 over 16, 15 over 16. All right. Same thing here. My limits on both sides would be 0. 0. My limit's on both sides. I really want to focus on cases 1 and 2. And let's just talk about relating graphs and let's talk about graphs a little bit more, and especially with case 2. So case 2, graphs. Let's make this bad boy. Let's make this wild. Wow. 0, obviously, and 5. This is what a horizontal asymptote of 0 means. All right? Both my limits go to 0. Let's call this bad boy g of x. If I were to match this with an equation, I see this and I have to think my equation is bottom heavy. All right. This video is getting to be, it's approaching the 12-minute mark. I want to keep it below that. These case 1 and case 2 are by far the most important, right? Keep in mind, like how graphs look. Horizontal asymptotes and slant asymptotes are all about end behavior, all right? So just what are the ends doing? We're going to 2 in this one. We're going to 0. We're hugging the x-axis. Think my equation is bottom heavy. Think that my equation is even. Those are the two biggest things.